Hello, welcome to 7.6 homework help. Yeah, I paused it before the bad word. Anyways, let's get started. Here we go. So, what angles of rotational symmetry are there for a regular pentagon? This is throwback to last unit, unit 6. Alrighty. So when you're talking about rotational symmetry, that is the equation. You have 360 degrees divided by number of sides. You remember that? Kind of? Yes, you do. Yes, you remember that. 360 degrees divided by number of sides. Alrighty. So, usually just write n, divided by n. How many sides does a pentagon have? Okay, so 360 divided by 5. Okay, 360 divided by 5. You can do it on a calculator. Doesn't bother me. 360 divided by 5. 72. 72 degrees. So, if I were to rotate a regular pentagon, remember, regular means all the sides are the same length. All the sides and all the angles are the same. So it's going to be 72 degrees. And then I would rotate another 72 degrees. Okay. So you're just adding 72 degrees onto itself all the way up to 360. Go ahead and pause me and do that. Okay, you should get 216, 288, 360. Okay. So there you go. There are your angles of rotational symmetry for a pentagon. So if I rotate a pentagon, a regular pentagon, 72 degrees, it will rotate exactly onto itself. Okay, and that's true for all of these angles. All right, so you're going to do that for a hexagon. Okay, and then you have to work backwards on number 3. Number 4. On each coordinate grid below, perform the indicated transformation. Oh, don't look. It's not an energy drink. They're terrible for you. Okay. I don't know which one of these I want to do. Okay, well, we'll start with number 4. We'll see if maybe I'll also do 5. So we're going to reflect point P over line J. Okay. So don't just count away how many it is. That works if J is a straight line, like it's not slanted. Like the axes are straight, so vertical or horizontal lines, that works. You can just count away how far they are. Count how far away they are. So like for instance, if I was reflecting P over the x-axis, then it would just go, okay, P is 1 away from the x-axis, so P1 or P prime would be right here. Okay, but that only works if your lines are not slanted. Okay, so what we're going to do is I'm going to find, well, this is how we've been doing it, so I'll do it this way. I'm going to find the slope of line J. So my slope of line J, I don't know. Start here. It looks like I'm going down 1, and then, goodness, that's a lot. Down 1, 1, 2, 3, 4, 5, 7. Looks like I'm going down 1 over 7. I don't know why I got that out. So I'm going down. My bad. Wrong thing. So I'm going down 1 over 7. Negative 1 over 7. Let me double check that with another point on line J. Here's another point down 1, 1, 2, 3, 4, 5, 6, 7. Yeah, okay. That's just All right. So then it's going to be perpendicular to that. The line connecting P to P prime is going to be perpendicular to J. So I'm going to flip and switch my slope, flip and switch, so I get positive 7 over 1. And so that's what I'm going to use. So starting here, I'm going to go, well, I would be going up 7 and to the right 1, and up 7 to the right 1, but that doesn't help because I'm trying to get down here. So we have to do the opposite. We have to go down 7, left 1. So down 7, 1, 2, 3, 4, 5, 6, 7, left 1. And there is your P prime. Oops, lost it a little bit there. It doesn't tell you what to label it. That's okay. We'll just hey. We'll do P prime. Okay. The other way you could have done it is count up. Just count how far away P is from. Well, no. Do it that way. Do it that way. So there you go. Okay, I'll do this one too. So you're going to reflect point P 90 degrees clockwise around point C. All right, so first let's think about this. If I'm going 90 degrees clockwise, where about am I going to end up? Am I going to end up over here somewhere, over here somewhere, over here somewhere, over here somewhere? Okay, 90 degrees clockwise means I'm going in the way that a clock ticks, so I'm going in this direction. Yes? Okay, so clockwise means I'm going in this direction. All right. So what I'm going to do is I'm going to connect P, which is the point I'm rotating, to the point I'm rotating around, to my center of rotation. So I'm going to get a line. I'm going to get a line. Just going to connect these guys. There. Okay. So then 90 degrees rotation. So 90 degrees means I'm going to create another a line that is perpendicular to this. We are going to be perpendicular to said line. All right. So I'm going to figure out the slope. It just looks like it's over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. Okay. Here, sorry. We're going down 1, sorry, down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. That got away from me. So your slope is -1 over 1, or just -1. Okay. So then our new slope is going to be perpendicular to that. So flip it and switch the sign. Be positive 1 over 1. All right. So hold on 1 second, guys. I need to pause you. Sorry. Sorry, someone wanted to talk to me. It was awful. No, it's fine. Okay, so anyways, our new slope is 1 over 1. So we're going to start at point C, which is our point of rotation, and we would go up 1, right 1. But be careful. We're rotating. We already said we're rotating this way, right? So if I went up 1 over 1, up 1 over 1, and so on and so forth, okay, it would end up like over here. That would not be a 90. That would be like, that would be a counterclockwise rotation. Okay. So clockwise. So that means we just have to do the opposite of our slope again. So instead of going up 1, right 1, I'm going down 1, left 1. And then down 1, left 1. Oop, okay. And then down 1, left 1. And down 1, left 1. Okay, how far do you need to go? Well, how many times did I do that to get to point P? So starting at C, I went down 1 over 1, so that's once. Down 1 over 1, that's twice. down 1 over 1, that's 3 times, down 1 over 1, that's 4 times. So I'm going to do the same to keep them the same distance away. So I'm going to go down 1, left 1 once, down 1, left 1 twice, down 1, left 1 3 times, down 1, left 1 4 times. Okay, so my new P point is my new point of P. It should be right on that. It just messed up my dot. It should be right there. Right there. It should be at the point, what is that? -5, 1, 2, 3, 4, 5, 6. Oh no, -6, 0. It should be at -6, 0. Because my point looks a little wonky. All right, that should be your new point. Okay, so what did we do? We found the slope of line CP. So we connect them with a line. We found the slope. Okay, this line, which I'm going to add in, is going to be perpendicular. Okay, perpendicular. It's going to form a 90-degree angle. So let me pause you again and draw in my line so I can show you. Okay. So see how these two lines, they form a 90-degree angle. That is because they are perpendicular to each other. When you rotate 90 degrees, clockwise or counterclockwise, you're going to form a 90-degree angle. Okay, so this guy is, I did that last time too. P prime, or whatever you want to label it, because it didn't tell you what to label it. Okay. 6 through, there's only, okay, 6 through 8. What transformations would map triangle ABC onto XYZ? So similar to what we did in class on Friday, today, whenever you're watching this video. Okay. So how am I transforming this triangle to map it directly onto this one? I am rotating it 180 degrees, and then I'm going to translate it so it fits. Let me show you here. Okay, so we're going to watch, this top point is point A. This top point is point A. I can't label it because it won't stay on there. Okay, so watch the top point. So that's A. I'm going to rotate it 180 degrees. Boom. I rotate it 180 degrees. Okay, now these look exactly the same. So point A needs to end up right here, which is point X. Point A needs to end up right there. Okay, so I rotate 180 degrees, but now they're not on top of each other yet, so then I have to translate. Okay. So when you're writing that, rotate 180 degrees, and it doesn't matter if you go clockwise or counterclockwise, you get the same thing. So you can just say rotate 180 degrees and then translate so that now is when you're matching up your points. So point A lands on point X, or you could say point C lands on point Z, or point B lands on point Y, whatever one you want to say. So that I'm going to say vertex A will be fancy. Lands on vertex X. Oh, X. Okay. Go back here. So we rotate 180 degrees, and then I translate so that this is point A, this is point X, so that point A lands on point X. All right, so that's number 6. Number 7, similar. Number 8 is also similar. All right. So trying to figure those out. Remember, we're not using, well, we're using degrees of rotation, but we're not saying like translate this many units because we don't know. There are no numbers. So you're just translating until you match up a point or a vertex. Okay. Okay, 9 through 12. To prove triangle congruency using side, 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 what other information would you need? So I did this one as an example. So this is what you're given. You're given 2 triangles with TQ is equal to or congruent to WY, Okay, they have the same mark, so they are congruent. And then TP is congruent to WX. They have the same mark. So if I'm going for side, 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 what other information would I need? Well, side, side, side means 3 congruent sides. So I know this side is congruent to that side. So that's, sorry, goodness, 1 congruent side. TP is congruent to WX. That's another congruent side. So that's 2. But I need to know 3. So to prove using side, 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 I would also need to know that QP is congruent to YX. Okay, that will give me my 3rd congruent side to use side, side, side. I would also need to know that QP is congruent to YX, and then I could prove triangle, that these triangles are congruent using side, 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 because all 3 sides would be congruent. Okay. I'll do one more of these. Let me do, I guess let's do number 10. To prove triangle congruency using side, angle, side, what other information, my A looks kind of faded out. Hopefully it isn't on yours. Anyways, what other information would you need? So we're going for side, angle, side. So SAS means side, angle. That means there's an angle in between, and then side again. Okay. So if we look at our triangles, what are we given? Well, we're given this side, FC, is congruent to PJ. So side FC is congruent to PJ. And we're told that angle C is congruent to angle J. Angle C is congruent to angle J. So we have side, angle. So what else do we need to know? We need to know this side. We need to know that side CL is, congruent to side JR. Okay, it has to be that side. It cannot be this side. That will give us side, side, angle. Okay, you have to go with the order. Side, angle, side. The angle needs to be in between 2 sides. Side, angle, side. So we need to know side CL is congruent to side JR. I'll draw in my little congruency symbol. Oh yeah, that was bad. Let me try one more time. I don't know why I ever try and just delete. It never lets me. Okay, all right. Okay, that's fine. Oh, that was actually pretty good. Okay, so that's number 10. To use side, angle, side. All right, so then try 11 and 12, and that's all your homework. Make sure I will get caught up on other homework over the weekend. I highly, highly, highly recommend. Remember, make sure you know how to do those transformations from 7.5 homework. All right.